So this is just going to be a continuation of the notes for solving equations. I planned to be in class, but unfortunately had a meeting, so sorry about that. I have both the notes and I have my calculator up because I'm going to be using that calculator. So please, when you see me using my calculator, do the same. So we're just going to go back to number 2 and work on solving these equations. So again, our first step is going to be to distribute. And if you look at number 2, there are no parentheses, so we actually don't have to distribute. So we're going to skip that step. Step 2 says to combine like terms on each side. So if I'm looking at problem number 2, some of you might want to draw that line through the equal sign because that separates the two sides. So if I look at the left-hand side, I have a constant 1.2 plus 4.3x, which is a variable term. Those aren't like terms. I cannot put those together. And then on the right-hand side, I only have 9.8, so I can't put that together either. So I can skip step 2 also. Step 3, move the variable to one side. So if you look at that, we have our variable x on the left-hand side. So that's already done for us. So step 4 is the first step where we're actually going to have something to do. So it says move constants to the other side. So again, our variable is on the left-hand side already, right there. So we want to move this 1.2 to the other side. And so to do that, we're going to do the opposite operation. So that's a positive 1.2. So we are going to subtract 1.2. I'm going to zoom in so I can write a little easier here. So we're going to subtract 1.2 from both sides. So I'm going to subtract 1.2. So when I do that, this 1.2 and negative 1.2, those are a zero pair. They cancel out. I'm going to be left with a positive 4.3x, or I'm not going to write the positive because it's understood if it's not there, equals, and so this is where I'm going to use my calculator. So I'm going to do in my calculator 9.8 minus 1.2. So I'm going to type that in. So 9.8 minus 1.2. So my screen is messed up just a little bit here. I'm going to see if I can fix that. There we go. So we can see all of it. So 9.8 minus 1.2 is going to be 8.6. So I'm going to write that here, 8.6. All right. My next step, so if I go back to the steps, are to multiply by the denominator or divide by the coefficient. So if you look at our problem, we have a coefficient of 4.3. So we're going to divide by that coefficient. We want to get x by itself. So to undo that math, we're going to divide. So we're dividing by 4.3 on both sides. Divide by 4.3. So on the left-hand side, 4.3 divided by 4.3, that gives us a 1. So those, yes, they cancel, but again, that's a 1x or just x, same thing, equals. On the other side, I'm actually going to do that math. So 8.6 divided by 4.3. So if I go back to my calculator over here, I have 8.6 already. So if I just push divide, it's going to do ANS. That means answer. So it's going to take the previous answer, 8.6, and I want to divide by 4.3. So I get that. You could have just typed it in, 8.6 divided by 4.3. Whoops, 4.3. And that would work also. So our answer is going to be x equals 2, or 1x equals 2. Okay. So the next one is going to be number 5. So number 5, we have a word problem. So I'm going to read it here for us. So it says, a candy store sells 8-pound bags of mixed hazelnuts and cashews. If C pounds of cashews are in a bag, that's going to be important. We need to know, what do our variables stand for? So C is pounds of cashews. Really important. C pounds of cashews are in a bag, and the price P, so price is going to be P. So I'm going to underline that also. Price is P. If the price P of the bag can be found using the formula, so there's our formula. If one bag is priced at $18.11, so that's really important. This is P, this is our price. How many pounds of cashews does it contain? So pounds of cashews, again, was C. So C is what we're looking for. That's our question mark here. So really important that you recognize they gave us P. So right here in this formula where P is, we're going to replace it with $18.11. So I'm going to just rewrite this equation with $18.11 plugged in for P. So I'm going to have $18.11 equals, again, because I just replaced P right there with $18.11, equals 2.59C plus 1.72 times 8 minus C. So this is going to be a little bit more difficult of a problem to solve. So our first step, if you go back to the steps at the top, our first step is going to be to distribute. So we are going to distribute right here this 1.72 to the 8 and 1.72 to the negative C. Everything else in our problem is going to stay the same. So I'm going to go ahead and just bring all of this down. So 18.11 equals 2.59C. All right, and here's where I'm distributing. So I'm going to do 1.72 times 8. So I'm going to go back to my calculator here for a second. 1.72 times 8. So my calculator, 1.72 times 8 is going to be $13.76. So plus $13.76. And then we do 1.72 times negative C, so that's just going to be negative 1.72C. It's negative because a positive times a negative is a negative. All right, so now we're going to go to the next steps. Our next step says to combine like terms on each side. So on my left-hand side, I only have one thing. I can ignore that for just a second. On my right-hand side, I see that I have 2.59C and negative 1.72C. So I'm going to combine those. I'm going to read it from left to right, and that's what I'm typing in. So I'm going to type in 2.59, I can't type the variable, so 2.59 minus 1.72. So on my calculator, let's see if this is not working. Let me delete that. 2.59 doesn't seem to be working. So let me try a new document. Okay. One more time. 2.59 minus 1.72 is going to be 0.87, so basically 87 cents. So I'm going to rewrite this as 0.87C. I'm going to bring down my plus $13.76. On the other side, I still have $18.11. All right, so I combine my like terms on each side. Now I need to get the variables all to one side. Well, I have my variable all on this side. So the next step is to get my constants to the other side. So this 13.76, I need to move to the other side. So I'm going to do the opposite, which is subtract $13.76. So subtract $13.76. Okay, so I'm going to do that math. I'm going to use my calculator to do this. So $18.11 minus $13.76. So $18.11 minus $13.76 is going to be $4.35. So 4.35. So I'm going to write that down. 4.35 equals 0.87C. My last step is to either divide by the coefficient, which is what we're going to do. We have a coefficient right here of 0.87, right? So we're going to divide by 0.87. So divide by 0.87. So these will cancel out, which is what we want to happen. So this 0.87 right there, those cancel out. That gives us a 1C, or just C, equals. On the other side, we have 4.35 divided by 0.87. So 4.35 divided by 0.87 is 5. So C equals 5. I am going to rewrite this. I think it's really important that my C was on the right-hand side. I want to leave it on the right-hand side. I don't want to just move it because I can. So C equals 5. So that's correct. Again, you could write that as just C equals 5 this way also. Okay. So that means it said how many pounds of cashews does that bag contain? So that would be 5 pounds of cashews for $18.11. All right. We're going to go now to number 7. It looks like is the next one. So number 7, we have some parentheses. So we're going to distribute first. So again, distribute means to multiply. So we're going to do 2 times x is going to be 2x. 2 times negative 3 is negative 6. Equals, we don't have to distribute on this side, so 2x plus 5. All right, at this point, some of you might want to draw that line down your equal sign. And now we need to get our variables all to the same side. So you can choose at this point. I generally move to the left, variables to the left. So I want to move this 2x to the other side. So to do that, I do the opposite. So I'm going to subtract 2x. What I do to one side, I have to do to the other side. So subtract 2x. So when I do that, something weird is going to happen. So this 2x and the 2x on the negative 2x on the right-hand side, these two, those cancel. That's a 0 pair. That's what we wanted to happen. What also happens, though, is these two cancel. A 2x and a negative 2x. Again, that's a 0 pair. Those are going to cancel. So what we're left with is negative 6 equals 5. So this is like number 9 that we did earlier. So you have to ask yourself, is that a true or a false statement? Our variables are gone and we're left with a statement. So is negative 6 equal to 5? Your answer should be no. It is not equal to 5, right? This is not equal, so that's how you say it's not equal. So this is a false statement. So when it is a false statement, there is no solution, no number that we could come up with is going to ever work. So there's no solution. There is a symbol for no solution. It looks like a 0 with a slash through it. So if you write your zeros like that, you might stop because that means no solution. So again, no solution is when your variables go away and you're left with a false statement. So let me just go back real quick to number 9. It was all real numbers because our variables here went away, but we were left with a true statement. So when we have a true statement, it's all real numbers. When we have a false statement that's left, we have no solution. All right, number 8. So number 8, we have some parentheses with some distribution, so quite a bit here. So I'm going to go ahead and draw my line through my equal sign, just to make sure I get that all straight up. All right, then we're going to start with distribution. So I'm going to start on the left. So I'm going to distribute 0.3 times 12. Again, I'm going to go back and forth between my calculator here. So 0.3 times 12. So 0.3 times 12 is going to be 3.6. So 3.6x. Then we're going to do 0.3 times negative 16, right? Make sure you keep that sign, so that's a negative 16. So back in my calculator is 0.3 times negative 16 is negative 4.8, so minus 4.8. That's a point, not a comma. Equals, on the other side, same thing. We're going to do 0.4 times 12. Let me undo that for you. 0.4 times 12. So 0.4 times 12 is going to be 4.8. So 4.8. Then we do 0.4 times negative 3x. So 0.4 times negative 3 is negative 1.2. So minus 1.2x. All right, our parentheses are gone. Now we want to make sure that we can combine any like terms on each side. So on this side, I have an x and I have a constant. This side, I have a constant and I have an x. So nothing that I can combine over here, nothing that I can combine over here. Our next step, get all your variables to the same side. So I have a 3.6x here and I have a negative 1.2x here. I want to get those to the same side. So this negative 1.2, I'm going to move to the other side. Again, I do that by doing the opposite operation. So plus 1.2x, right? The opposite of subtraction is addition. So what I do to one side, I have to do the other side. So plus 1.2x. When I do that, if you need to use your calculator, please do that. We're going to do 3.6 plus 1.2. So 3.6 plus 1.2 is 4.8. So 4.8x, we have minus 4.8 equals 4.8. So I know that looks a little funny, but please don't, make sure you use your calculator just to make sure that those are correct. All right, next step, we want to get our constants to the other side. So our x's are all on this side, so I need to move this constant to get it to the other side. So we do that again by opposite operation. So I'm going to add 4.8. When I add to one side, I have to add to the other side. So plus 4.8. So when I do that, negative 4.8 and positive 4.8 cancel. On my right side, I have right here 4.8 plus 4.8. So I'm going to do that. 4.8 plus 4.8 is going to be 9.6. So 9.6. On this side, I still have 4.8x. Last step is to get your variable by itself. So we want to undo this operation. So right here, 4.8x means 4.8 times x. So we do the opposite, which is divide. So divide by 4.8, divide by 4.8. So we do that. If you use your calculator, 9.6 divided by 4.8. Many of you already know probably that that is 2. So our answer here is going to be x equals 2. All right, last one. This one's a little bit tricky. So we have a 12-inch candle and an 18-inch candle that are lit at 6 p.m. The 12-inch candle burns at 0.5 inches, or half an inch basically, every hour. The 18-inch candle burns 2 inches every hour. At what time will the two candles be the same height? So I kind of give you a hint there. Write an equation and then, you're going to solve. So we actually need an equation that represents one side is going to be our 12-inch candle and the other side is going to be our 18-inch candle. If we want to know when are they the same, that means when are they equal to each other, right? Same means equal for us. That's an equal sign. So our 12-inch candle starts at 12 inches, right? So we're going to start at 12. And then if it's burning, this is really important. If you're burning a candle, the height is decreasing. So it's decreasing. So subtracting half an inch, 0.5 inches. So I'm going to call inches in. Actually, no, I'm going to use H for hours. So it's 0.5 inches every hour. So struggled with that a little bit. So it's going to be every hour. And we want to know when is that equal to the 18-inch candle. So if the 18-inch candle starts at 18 and it's burning at 2 inches every hour, so we're going to subtract 2 inches per hour. So again, 2H. So there's our equation. Now we're going to solve. All right, I'm going to draw my line through my equal sign. So first step is to distribute. We don't have to distribute. Second step, get all your variables to the same side. So you can do this a couple ways. I personally would move this negative 2h to the other side. I said this the other day. I'm better at adding than I am subtracting. So if I can add 2h, I personally would prefer to do that. So I'm going to add 2h here. All right, we're going to have 12 left there. If you need to use a calculator, please do this right here. We have negative 0.5 plus 2. Hopefully you know that, but just in case, negative 0.5 plus 2 is going to be 1.5. So plus 1.5h equals 18. So we got all of our variables to one side. Now we're going to get our constants to the other side. So our variables are here. So we want to get this 12 to the other side. So we do that by doing the opposite. So the opposite of positive 12 is negative 12. What I do on one side, I have to do to the other side. So when I do that, 12 minus 12 is a 0 pair. That cancels. I'm going to be left with 1.5h equals 18 minus 12. Hopefully you know that. If you don't, that's going to be 6. And then our last step is to get our variable by itself. So this 1.5 again means times h. So we want to do the opposite. So we're going to divide by 1.5. Divide by 1.5 on both sides. So we're going to be left with h equals 6 divided by 1.5. So use your calculator. 6 divided by 1.5 is going to be 4. So what that means, the question was, at what time will the two candles be the same height? So this is really important. After 4 hours, they're going to be the same height. If the candles were lit at 6 p.m., so 6 p.m. plus 4 hours, what time is that going to be is the question. So if you count from 6, you add 4, then hopefully you know that that's going to be 10 p.m., right? 6, 7, 8, 9, 10. So at 10 p.m., both candles are going to be the same height. If we wanted to know how tall, it doesn't ask this, but this is really important. If we want to know how tall the candles are going to be, we can take our 4 and plug it in. So you only have to do that for one of them because they're going to be the same height. I personally would use this one. I think it's a little bit easier. So if I plug 4 in, so I have 18 minus 2 times 4. Well, 2 times 4 is 8, so 18 minus 8 is going to be 10 inches. So both candles would be 10 inches tall at 10 p.m. So just a little bit extra there on that. All right, that looks like it's the end of those notes. So we will actually put those in our journal when I am back in class. So